Morning, everyone. I'm just bringing up that past final. All right, got it. How are we doing? Morning, everyone. Questions while we wait for others to come in? Benjamin, can you? Thank you. Jacob is asking if we're able to solve optimization problems involving Schrader functions. I believe you can. Yep. Joe is asking what time will the final open. I sent out an email, perhaps confusing, because I actually hadn't looked at the final exam schedule. I only had the tentative final exam schedule in mind. If you go to the link I gave, it'll take you to the actual final exam where everything is spelled out in complete detail. So the final exam is the final exam schedule is very, very clear, and there's no ambiguity. Benjamin is asking what constant acceleration is required to increase the speed of the car from 30 miles an hour to 50 miles an hour in 5 seconds. And you want a constant acceleration, right? So acceleration should be some constant. Now, if you have the acceleration, we can work backwards, right? What is the velocity? The velocity is the antiderivative of the acceleration. What function has derivative c? The answer, of course, is ct plus d, where d is any constant. Now, you're starting out with a speed of 30. So when t is 0, you're already going at 30. So the velocity is now ct plus 30. And at 5 seconds, 5 seconds later, what is that? This is 5c plus 30. And that should be 50 miles an hour. So 5c is easily seen to be 20. And so c is equal to 4. So 4 is the answer. right? That's what we wanted. We wanted to know constant acceleration. I mean, obviously, you could have guessed, right? You want to go from 30 to 50 in 5 seconds. So you want to go 20 miles an hour faster in 5 seconds. 20 divided by 5 is 4. But this is the idea. And you can use this idea to answer other questions. Effie is asking if we have class on Thursday. We do not. Wednesday. So our next class is the last class. There it is. Questions? Do we want to go over anything in particular? Are we moving on with that old final exam? What do you want to do? Anything? No? Old final then? Old final. If you have questions in the meantime, feel free to stop me. Where are we? I want to say we're on number 6, which is asking us to express 8 as the sum of 2 non-negative real numbers. Such that the sum of the square of the first and the cube of the second is as small as possible. Sum of the square of the first and cube of the second is as small as possible. An interesting question. There will be no epsilon delta on the file. All right, so you know what to do, right? We're going to introduce some variables. So let x and y be real numbers. Well, people, if you want me to do some specific questions, that would be very nice. So please suggest those questions. Right? I mean, I see people asking for questions with variables and optimization and so on. So please give me some examples of those. So we're going to let x and y be positive numbers, right? 2 non-negative real numbers. And we want 8 to be the sum. And what do we want to do? We want to minimize what do I want to call that? Let's call it S. Minimize S. The sum of the square of the first one and the cube of the second. This is what we want to minimize. And of course, from here, we see that y is 8 minus x. So we have this. And consequently, we want to minimize this. So you know what to do. Right, we want to minimize this. So you know what to do. We are going to differentiate with respect to x. So the derivative, 2x plus 3, a minus x all squared, times the derivative of the inside, times negative 1. I think we're going to have to expand this. So this times 2. So is that 48? And 64 times 3, 18, 19, 2. So this is minus 3x squared plus 50x minus 192. I don't know how that factors. So let's use the quadratic formula. Is this correct, by the way? Does anybody have that? Let's use the quadratic formula. Right, I mean, we're looking for critical points. So, negative b, square root of b squared, minus 4ac, all over 2a. All right. Thank you, Matt. And what is that? 192 times 12. What is that? That's the one. 1504 minus 2500, so that's 996. Is that correct? What is that? $996. $150, 161 times 2? No, it's not it at all. 16. Yeah. No. 166. 166, which is going to be 2 squared times 83. 83 by 23. Why was I completely off? Yeah, of course that makes no sense. Where was my mistake? 2, 3. It was a 3. Thank you. That makes a lot more sense. So that's, 3204, thank you. And that's 2,500, so that is 196. And what's the square root of 196? Is that 13? 13 squared? No. Square root of 196? 14? 14, very good. So, minus 36 over negative 6, or 64 over negative 6. So that is either 6 or whatever that is. 32 over 3. 6 and 32 over 3. Very good. All right, here we go. We're on the same page. Perfect. So let's draw a first derivative chart. This is almost 10. So it's going to be bigger than 6. And we are looking at this thing. So for values very close to 0, it's going to be close to 0. That's going to be close to 0. So the whole thing is going to be close to negative 192. So it's going to be negative for sure. If you plug in 7, I mean, it's not immediately clear, but this is going to be almost 150. 7 times this is 350. So the difference is going to be bigger than 200. Minus 192 is going to be positive. And if you plug in a large positive number, if you factor out an x squared, right, this can be treated as x squared times minus 3 plus 50 over x minus 192 over x squared. For large values of x, this goes to 0, that goes to 0. So the stuff in the bracket goes to negative 3. This goes to infinity. So the whole thing is going to be negative infinity. In other words, negative. Here we go. I mean, let me point out that this, while not wrong, we probably should have restricted our domain a lot more, right? What was the original question asking for? 2 positive numbers. So if we look at this, of course, if x is bigger than 8, this is no longer going to be positive. So our domain, which we had suggested was this, actually becomes 0 to 8. So this, which is almost 10, we're going to remove that and stop our interval at 8 and say that this is not in the interval. What was our question asking for again? What was it asking for? Oh, right here. Sum of the square of the first and cube of the second is as small as possible. Right, so it's clearly here we have an absolute minimum occurring at 6. There you go. So x equals 6. Y equals 2. And s is going to be 6 squared plus 2 cubed. So 36 plus 8, 44. If we had plugged in 8 minus y for x, it would have been much simpler. Very good. Very good. Very good. Because, of course, when you differentiate, you would have just gone to y or to 8 minus y, and this would have been the y squared. I see what you mean. Interesting. Very well. But same answer, and that's what's important. Right? I mean, the only issue was here that we didn't have a really nice quadratic polynomial, but quadratic formula works very well. And you could expand this before differentiating. That would not actually be much easier. But the point being, you have options here. You have options. You can do whatever you want. And the answer is the same, as you would expect. Would it have been counted wrong if in the final to restrict the domain to 0 to infinity? The problem is, as we had pointed out, right, if you keep going, if you kept going, your function decreases after 32/3. And if you look at your original function, which was x squared plus 8 minus x cubed, as x goes to infinity, this is going to go to negative infinity. In fact, your whole s goes to negative infinity. So you don't have an absolute minimum. So the question itself would have been incorrect. But by restricting the attention to positive numbers only, so making sure that this is positive, meaning that x cannot be bigger than 8, then you're guaranteed an absolute max and an absolute min. So yes, it would have been incorrect to use 0 to infinity. Somebody was asking Jacob here. A steel pipe is being carried down a hallway X feet wide. So you've got a hallway X feet wide. At the end of the hall is a right-hand turn into a foot wide hallway. So you're carrying a steel pipe, which is going to be represented by this. And you see the issue, right? When you get to the end, you have to make a turn. So how long, what is the length of the longest pipe that can be carried? Everybody with us here? What is the height of the hallway? Very nice. Very nice. Let's say it was a crawl space though. All right, so we're looking for the length. And let's call this, so let's introduce some variables. Let's call this the length of the pipe. So we want to maximize the length. Maximize the length. Subject to some conditions. What are the conditions? Well, I mean, you have a few triangles, right? You have this triangle right here. You have that one right there. And this angle is the same as this angle. So what do we want to do? Let's call this H, and let's call this L. We're just introducing some variables here. And what? We can express L in terms of H and L here. right? Because let's call this diagonal D1, and let's call this diagonal D2, and by the Pythagorean theorem, x squared plus h squared is equal to D1 squared, and also L squared plus y squared is equal to D2 squared. So D1, so L, which is equal to D1 plus D2, right? This piece plus that piece is the square root of x squared plus h squared plus square root of L squared plus y squared. So if we can get a relationship between h and L, then we're good to go. But these two angles are the same. So whatever, tangent of that angle is opposite over adjacent, h over x. And tangent of that angle is opposite over adjacent, y over l. Is the width of y the same as x? We don't know that. We don't know that. We have to assume that they are different. So you see we have a nice relationship between h and L. Maybe we could say that h is xy over L. So if you replace that in here, this is x squared plus xy over L, all squared, plus L squared. So you see, what we have managed to do is rewrite everything in terms of one variable, L. And we want to maximize this. So fine. So differentiate. I mean, maybe we want to discuss a domain for little l here. Obviously, being a physical problem, we don't want negative lengths. So L should be at least 0. In fact, some of you are going to want to use an open interval, not including 0. That's fine. That's fine. How large can L get, though? That's not immediately clear. I think you could come up with a maximum, but let's not worry about that for now. Maybe it's not going to play a role. Maybe it is, maybe it isn't. We'll see. Take the derivative. What happens? Times the derivative of the inside, which is 2xy over L, times negative xy over L squared. Plus 1 over 2 square root. That seems very complicated. I can only wonder if mistakes have been made here. So this is negative x squared y squared over L cubed square root. All right. Right. But I mean, would it though? Would it really make a difference if we knew what x and y were? These would just be numbers. I mean, you'd have everything the same, but with numbers instead of x and y. It wouldn't really make it any simpler. Convince yourselves of that it wouldn't make it any simpler. Take x to be 1 and y to be 2. It's not going to make it any simpler. Where's the 2x? What 2x are we talking about? Did we differentiate x and y? Shouldn't it be in the numerator of the first term? You tell me. What are we differentiating with respect to? Right, that's going to answer both Effie's and Rachel's questions. There's only one variable here. We are differentiating with respect to L. Not x, not y, only L. L is the only variable here. All right, let's put everything over common. I don't know that I want to erase this, so let's not. Let's put everything over a common denominator. All right. There we go. So first of all, convince yourselves that there are no critical points coming from the denominator except for L equal to 0, which would make this undefined. If L is anything else, this is going to be a positive term. this is going to be a positive term. And because x and y are themselves, I assume, non-zero, then the only critical point coming from the denominator is L equal to 0. What about the numerator? What about the numerator? That seems difficult. Have I made a mistake in the derivative? Does everybody have this as the derivative? When is the numerator 0? When is the numerator 0? That's the question. All right. Well, it is what it is. Let's see if we can do anything with that. Square both sides to get rid of the square root. Oh. You see it? Do you see it? Right? If you factor out an x squared from here, this is going to be the same as, so take out an x squared. This is 1 plus y squared over L squared. And then put everything over a common denominator and take that out. So this becomes L cubed square root of L squared plus y squared. And now these cancel out. Very nice. Very nice. And you can cancel one of the x's. And so there it is. L is the cube root of x y squared. One critical point. Y is the left side x squared. Where do you mean? Left side, left side. I mean, I'm factoring out an x squared. People, where did I lose you? Y is the left side x squared. It isn't. Left side is just x. I'm factoring out, there's an x squared present in both terms, right? So factor it out. Square root of x squared is just x. Kamal is saying the right side. Well, I mean, I'm making this equal to 0. Right, so I'm bringing this to the other side. So it's x squared y squared. Then, yeah, that's all it is. All right, so why did it go from L to the 4 to L cubed? Put everything over common denominator here. This is square root of L squared plus Y squared over L squared. And then square root of the top divided by square root of the bottom. We'll get a L in the denominator to cancel with that L. All right, I think everybody's on track. So let's see what happens. I'll find an L, one critical point, a cube root of xy squared. Is this the correct critical point? I don't know that I feel good about this. No? Anybody have a different critical point? All right, let's assume that it's correct then. And if you take a number very close to zero, if L is very close to zero, this, first of all, the denominator is always positive, right? So we don't need to worry about that. Taking a number very close to zero, this is going to be close to zero. So this whole thing is going to be negative. And if you take a very large value of L, right? I mean, really the question is what is happening as L goes to infinity of this business. Factor out an L from here, right? Can I rewrite this as, let me say this is L times the square root of 1 plus y squared over L squared. So if you factor out an L from the whole thing, you'll be left with you'll be left with, if you factor out an L cubed, square root of this, minus x squared y squared, square root of 1 plus y squared over L squared. And as L goes to infinity, this goes to 0, so that goes to 1. So this whole thing goes to x squared plus y squared, x squared times y squared. Here, as L goes to infinity, this goes to 0. So the square root goes to square root of x squared, which is just x. This goes to infinity. So you have infinity minus a number, which is going to be infinity times infinity. The whole thing is infinity. In other words, positive. That's the only point I was making here. And there you have it. Something is bad. Something is bad because what does this mean? This means we have an absolute minimum. Which is certainly not what we wanted. What happened? Seriously. Well, I mean, this would be a very nice exam question. Very, very nice, in fact. Where did the mistake occur? Everything looks so good. Well, I wasn't actually expecting I was expecting some sort of symmetry, right? So, I mean, not an xy squared. I might have expected an x squared y squared or xy to the 1/3. That would have been fine as well. I was surprised to see this. But more importantly, where did the mistake occur? Anybody see where the mistake happened? Anybody? No? Well, I mean, let's say this. Try it again this afternoon. And I'll redo it this afternoon as well. We can discuss it on Wednesday, see where the mistake actually was. It's an excellent question. Excellent preparation for the final. All right. Questions? I mean, if only the derivative was negative of what we had, then everything would be very nice. I'm not sure what you mean, Kamal. Questions? Do we have a few more minutes? Do we want to do a question from the past final? The next one is... No, let's not do that. Well, I would expect it to depend on the values of x and y, right? And this critical point is exactly the point. Right, but as you pointed out, x and y are not going to be negative numbers. We do not have the fourth lecture, Kamal. We never had it. All right, perhaps a good place to end then. Redo this question this afternoon, tonight, tomorrow, and we will redo it together on Wednesday. Thank you all for coming, and I will see you Wednesday.